Hi everyone, thanks for joining in. Today I'll talk about the new or updated language features in Java 16, what these features are, why you need them, and how you can use them in your applications. But before we get started, a quick introduction. I work as a developer advocate with JetBrains. I'm a Java champion and I have authored multiple books on Java certification because I strongly believe writing a Java certification can take your Java skills to the next level. And just in case if you don't know already, last year Oracle introduced a new certification exam for Java developers. Now you can write just one exam and become a certified Oracle Java developer. I also work closely with developer communities. I co-lead the Delhi Java user group and Women Who Code Delhi chapter. At Women Who Code Delhi, I also lead the publication of Technology Grid, which is our monthly newsletter. Now, before I get started talking about the Java 16 features, let me take a step back and talk about the Java's release cadence, how the new predictable release cadence has impacted the features it delivers in every version, the developers who use it, and the enterprises. Java 8 was released in March 2014 after a gap of 3.5 years. Java 9 was released in September 2017, but the release cadence changed with Java 9. And now, every 6 months, we get a new version of Java in March and September, which means that in March this year, Java 16 would be GA. How do you think the new predictable release cadence has impacted the features? I believe that it's really doing well for the features. The features get the spotlight that they deserve. They don't have to wait for the star features to complete to hop on to the release train. Does anyone remember the compact strings which were released in Java 9, or do you only remember the module system? It's good for the developers as well. As developers, we get to work with the new features every 6 months and we don't really have to wait for a period of around 3 years and work with 100 features at the same time. It's great for the enterprises as well. They can take an informed decision when they want to move their applications to the new version of Java. They can try out the features, they know what's coming in the future releases, so they can plan their migration accordingly. These are the 3 features that I would cover in today's session: seal types, records, and pattern matching for instance of. These are just the language features. Of course, there is a lot that has been added to Java 16. And just in case if you're curious, you can find out using these links. You can check out the release notes. I really like to check out the Java language specification. Sometimes I also like to tinker with the Java virtual machine specification. You can visit this link to get information about all the JEBs, which is the Java enhancement proposal that went into Java 16. Now, this is one of my favorites. As a Java developer, I'm very curious to know how the API has changed from Java 15 to Java 16. And when you click on this link, you can view the differences which are highlighted in different colors, different backgrounds. And you can also check out what API has changed, methods that have been added, modified, or deleted. Introduced in Java 15, as a preview language feature, seal types continues in its second preview in Java 16. I will talk about what a preview language feature is towards the end of my presentation. The syntax of this feature lets you define, control, and restrict what other classes and interfaces can extend your classes or interfaces or implement the interfaces. But why do you want to do so? The goal of this feature is to let you define the possible hierarchies in your business domain in a declarative manner. Imagine you're working on an application for farmers or gardeners that helps them with information on certain type of plants. Let me hop on to my IDE now to show you how this works. For all the code demonstrations in this session, I'll use the latest version of IntelliJ IDEA, which is 2020.1. Now let me hop on to my editor. Before you can start using JDK 16 in IntelliJ IDEA, make sure that your project structure uses version 16 as your project SDK, and the project language level is also set to 16. You can also download a JDK using this dialog box. If you try to do that now, before Java 16 becomes GA, which is generally available, you would see only version 16, but as soon as it goes GA, you would be able to see the version 16 here. You can choose the version and the vendor, and you can download your JDK from this dialog, and you can also configure it. Now, and let me quickly create the base class for the hierarchy of plants that I was talking about. Let's call it the class plant. Now let me create a set of classes which extend this class. How would you want to use these set of classes or the hierarchy of classes? Let's say I have a class which says use seal type, and this is how perhaps I want to use that hierarchy in my application. So let me start with the method. I would call it process type, and the method parameter to this is of type plant, and that would be a simple set of if-else statements. Let me start with if I say plant is an instance of cucumber, what do you want to do? I want to call a method, let's say cucumber harvest, and I want to return the value. Now, what happens if the plant type is, let's say, plant is instance of climber? Then perhaps you want to sow the climber. That looks simple, because that's how the names of the methods which I have defined. Now, what happens if you say, if the instance of your plant is, let's say, herb, then perhaps you want to sell the herb. That's a good thing to do, right? I know it's getting boring a little bit, but we are there soon. Now, the last would be if plant is an instance of shrub, then what do you want to do? Perhaps you want to prune the shrub. Now, we are almost done, but we still need this case, and this is one of the favorites part of us developers. We simply have a return statement which says the control should not reach here. How many of you have written such comments and then simply say return a random value? Now, this is what I would say the problem area is in this code, because you cannot mandate or control what would be the exact subclasses of your base class plant. Now you would have to write code in your application to handle a plant in a more generalized way, which you don't want to do. You don't want a general solution for a specific problem. Let's say your application only handles these type of plants. Let's say at a later point, a developer adds an aquatic plant to this application. You don't have the instructions or the other details in place to handle how to work with an aquatic plant. So the sealed classes can be really handy here. Let me go back to the class plant and see how we can seal this class. I can say seal this class, and when I do that, all the subclasses are automatically in this case, IntelliJ IDEA makes all of them non-sealed, but of course you can make them either of sealed, non-sealed, or final. So let me make my herb class final. I want my shrub to be non-sealed, and let's make climber a sealed class. What happens when I make plant a seed class, I can define which classes extended. Since all these classes are defined in the same source file, I don't need the permits clause here. But of course, if they would have been in separate source files, then that would be required. So let me just move forward and add it here. I would say herb, the next one is shrub, and the next one is climber. Okay, now this is done, and in this case, if one of my derived class is a seed class, I would again have to follow the same rules. I have to define the permits clause, and now I say this, the climber allows cucumber to extend it. Now let me see what's the error message. Of course, I have to make it add either a final, a non-sealed, or a sealed modifier to the derived class. When I define any class as final, no other class can extend it. When I say a non-sealed class, that really means that class shrub can be extended by any other class without me needing a permits clause here. That's another way of saying that the author of class plant can control which classes can extend the class plant. But it thinks that the author is responsible. So when one of the derived class is non-sealed, that gives the author some flexibility, of course, with responsibility. Sealed class, again, it follows the same rules. Now I can go back to my this class, and in this way I could get rid of this code, and I could be very sure how it would work. The other benefit is, as of now, what happens if I just drop this else condition? I have no ways to exhaustively iterate over the set of values that are for valid values for class plant, and then have a method called or do some action on it. But that would be taken care with the seed class. Now let me show you other. So now this code would not work in this version, but pattern matching could be extended to the seal types, and one of the future versions you could see this being implemented, where you can exhaustively iterate over the type of plants that could be available. Compare that with the enums that we have. When we define an enum, you can define the exact instances or the values that an enum has. But with seed classes, you can control the types which are its derived classes. So let me just kind of comment it here. Now, what else can you do? Now let me go back to my plant class. In this case, the other thing that you see is when you define a class as a final class, of course, no other class can extend it. But if you don't define it as a final class, which is a non-final class, then any class can extend it. But the seal types, they fall somewhere in between when you can define which classes can extend it. As I mentioned earlier, this is more about how you want to model your business domain and not about the reusability. You are not saying that class plant could be reused by any other class that sees it. No, you are saying even if my class is plant is visible, only certain classes can extend it. And that is because I want to take actions on the specific type of plant. What else do we have to show? Okay, now when we talk about extending the seal classes, the classes should be either in the same package if they are part of an unnamed module, or they could be in separate packages if they are part of a named module. So a named module, as we know, can have multiple packages. So that's how it works. The other changes for seal types in Java 16 is the introduction of conceptual keywords. And the other one would be the local types. They are no longer allowed to be subclasses of the seal types. So for the seal types, you get to create secure hierarchies. You get to model your business domain better. You are decoupling accessibility from extensibility. If you are curious to find out the changes to the core Java API for the seal types, you can navigate to the definition of class and view that two methods have been added to it. One is getSeal and the other one is getPermitted subclasses. So let me go back to this class. Let me open the definition and I can find getPermitted subclasses. Similarly, if you navigate to the definition of interface constant DESC, you can view this node, which mentions that in the future, if the Java language permits, this may become a sealed interface. You are sure to see more usage of the seal types in the core Java API. The next language feature that I want to talk about is pattern matching for instance of, which is exactly it is. Applying pattern matching to the instance of operator. And in the future, you would see application of pattern matching to other language constructs like the switch statement and deconstructors. Now let me hop on to my IDE and see how we have been using instance of until now and how we can use it with the pattern matching. So let's assume I have a method which is output value in uppercase, which accepts a method parameter of type object, and I want to see if the value that you pass to it is of type string, and if yes, I want to print its value in uppercase. So I can use an if condition here. I say if object is instance of, I say string, then what do I want to do? I want to create a variable of type string and I want to cast my object to it. The next step is I want to call the method to uppercase on this local variable. So the problem here is the repetition here. I'm comparing object with the type string, then I'm defining a variable of type string and I'm casting that object to string. What if I could eliminate the redundancy here? So let's see how the pattern matching for instance of does that. I can define a pattern variable with the instance of operator now, and what does is it defines a local variable string. It casts and assigns the string value. Some bits of rules here. The scope of the pattern variable str is limited to the then part. If you try to let's say print the lowercase value of this variable, you say lowercase, this doesn't work because the pattern variable str is not accessible in the else part. And let's see what we could do now. Let me create a string, a field by the same name, and I assign it a value. And in this case, the else part here refers to the field str and not the pattern variable str. And let me kind of flip the condition here. So if I say this, now this str refers to field str and the else part refers to the pattern variable str. So it could be quite tricky and you need to kind of understand how it works. Now, the other modifications in Java 16 was if I cannot check this, because what's happening here is every object that I pass to this method or any object in Java would be an instance of the class object. So that's implicit and that's not allowed. Now, what else do we have? Okay, so we covered the scope, we covered how we were doing it earlier, how we do it now. I strongly believe that the real power of this construct lies in how you use it with the other constructs. Let me show you an example in another class. And this is one of the examples how we developers are used to writing the equals method. And let's see how pattern matching can help us make it more concise and more readable. Let me introduce a pattern variable here. And because of addition of that pattern variable, I can merge these nested if, and let's see, I can simplify it. And this is how it looks now. It's more concise and easier to read. I have another example. Now let's see how I can further simplify this method by using pattern matching for instance of. So whenever I see usage of the instance of operator, I can check whether I could use this feature here. So I can introduce a pattern variable because that line has gone now. I can merge these nested if statement. My IDE also suggests that I can remove the loop with a call to the remove if method. So this is how I like to see my method, but you can also inline this variable and make it more concise if you want to go that way. So as I said, the power really lies in how you use pattern matching for instance of with the other constructs to make your code more easier to read and concise. The last feature that I want to talk about is records. It gives you a compact syntax to model your immutable data. Before we get into the details, I want to talk about an interesting example. Imagine you walk into a store to buy trousers and see that all the trousers are of the same size. So depending on your size, they might be big, tight, or small for you. But if you are lucky enough, they might fit perfectly. But what if they don't fit perfectly? You alter them. And this is what we developers have been doing with the classes that we are used to work with. We define the fields as final, private, we define the getters, the setters, and the other bunch of methods, which is the constructors, toString, hash code, and equals. And this would change with records. Let's work with an example. Now imagine I have this code in which I want to store and retrieve the details of a person, and from the constructor it looks like the person has an age and a name. We are writing this person instance to a file and reading it from a file. Let's see how we are used to doing that without using records. So let me quickly go here and create a class person. Now let me add private final fields, which is name, and private final int age. Now let me add constructors. Now let me add the constructor for this class, and let me also add the getter methods, and what else? Let me add the equals in hash code. And what else do I want to add? Let me also add the toString method. So this was quite easy, I would say. So let me go back to the other class. Now let's see if we can run this class. Okay, and because since we are writing to file and reading from file, let me also implement the serializable interface here. Okay, right, now let me go back and see if we could run and get the person. We could save the person details and get it. Right, so this looks good. I think we are good to go. But what is happening here is, even though I could use the IDE to generate a lot of code, how do I make sure when the code is read by another developer, the developer knows that no changes have been made to the default methods that were generated. Ta-da! Welcome to the records. So let me kind of delete everything here and undo the creation of class person. And what I'm doing here is I would create record person. And so my IDE could already pick the names of my components. Let me modify this as age. Dun, dun, I think I'm done. I just need to make sure I implement the serializable interface because I'm trying to read and write this object to my text file. Now let's see if we could get this up and running. See? Yes. So what happened here, we could so we achieved the same amount of work with just one line of code and we are good to go. What other benefits do the records have? So let me go to this class and see what did we cover and what did we miss. We just witnessed a new type of declaration. We used records because did you see here that you could define a record the way you define or instantiate a regular class. So this was easy. And then we talked about, okay, so decompiled class. I'm not sure whether I have the time to show that to you, but a record extends the class java.lang.record. That essentially means that you cannot extend any other class in your record, and all the methods that are important like toString, hashcode and equals, these are important methods when you are using instances of a class to store in your collection classes. All of these methods and the getters as well, they are auto-generated when you compile your records. Yes. So now can I modify the default constructor and can that throw any exceptions? Yes, it can. So let me go to this class and let's say I want to insert a constructor. I could say I want to insert a compact constructor. In this case, I don't use the method parameters the way we use it for the regular classes. And what I can say is if age is less than, let's say, 0, I could throw new illegal argument exception. I say age can't be less than, cannot be less than 0. Now, so as you just saw, I could modify the constructor of this class. But what I can't do is I can't throw a checked exception. I cannot say instead of illegal argument exception, I cannot say exception. So this will not work if you see unhandled exception. So of course, if I can use, I can surround that with a try-catch block, but I cannot throw an exception from this constructor. So let me just move to the one that I had earlier. I can also modify and override the default methods that I have, which is public string to string, and I could say return ABC. So I could of course modify this, but I don't require that for this code. That was just to show that you cannot add fields to your records, because that's the whole purpose, that you define the state of your record using the components or the values that you pass to the record when you initialize it. I can't say string full name. This is not allowed. If you see instance field is not allowed, but of course I could say string get uppercase name, and I could say return name dot to uppercase. So this is allowed. I can add an instance method to a record, but not an instance variable, which would be a field. I can also add static variables. I can say static int count is equal to 0, and I could also say static int get count, and I could return plus plus count. So what else can we do? Yes, the other interesting thing is that the records, they are truly immutable and you cannot change the value of the fields using reflection. How do I know that? I have code to show that to you. I say use reflection. So this, I have already written some code to show how this works. So I have this method which is change final field values for non-record. And in this case, so notebook is a regular class. So if I navigate to the definition, I have a private final field, and I'm setting the value in the constructor, and in this case I initialized it with the value 10, but I am using reflection to change the value to 1000. I'm trying to do the same with a record. So point is a record. Let me go to the definition. So this is a simple record which has two components, x and y, and I'm trying to instantiate this with a certain value, and then I'm trying to change this to another value. And let's see if we can see if the values are, if the value change for records and for non-records. So if you see here, using reflection, I was able to change the value of private final fields of a non-record class, which is notebook. Initial page count was 10, but the new page count is 100. But when I try to do that with a record, I get an illegal access exception. So the data that you define using records, they are truly immutable. Okay, so let's talk about the generic records. Let me create a record. Let's say the name of the record is parcel, and I can say public record parcel, and then I pass it a type parameter, and my components are contents of type T, and I have double weight. So this is my record with generics. Let's see how you can instantiate it. Let me create another class, which is class table. So this is just a dummy class. And how could I instantiate parcel? I can say parcel table, parcel is equal to new parcel, and I can say new table, and let's say the weight is this. So this is how I can create a generic record, and I can also instantiate it. I can also add annotations. I could say this is not null. So this is how I can also add annotations to the components of a record. The last point that I want to talk about for records is creation of local records. Starting Java 15, you can also create local interfaces, local enums, and local records. This method defines a local record, and using this local record, it processes the stream from a collection which is passed to this method here. Thanks everyone for attending this session.